Great. Well, thank you so much, Matt. MacDevOps is one of my favorite conferences. When I was at the first Objective by the Sea when I was still in college, Matt and JD sat right behind me and said some very kind words and encouraged me to enter this field. And so it's really special to be here. So thank you so much. Today's talk is the miseducation of macOS security internals. A nice long title for you. And as Matt alluded to, I figured I'd touch on this first. But last year I gave a talk called Xprotect, Stop, Drop, and Shut Malware Down Before It Opens Up Shop. I wish I could keep it as on point this year. It's not going to be quite as perfectly aligned. But this year, obviously, will be Lauryn Hill. My name's Stuart Ashenbrenner. I work at Huntress, where we build managed EDR, which is now available on macOS as well. I'm a macOS researcher there. You can find me across most socials, Twitter, the Mac admin Slack, and GitHub and things like that at Stuart J. Ash. When I'm not working, I'm a girl dad. I love reading books, watching basketball, and of course, 90s and 2000s hip hop. Lastly, I am one of the primary maintainers on an open source project called Aftermath. It's an incident response framework owned by Jamf, and so I hope you can check it out. There's a lot of cool features there for any incident response needs you have, and of course, it being free and open source. So let's get into the syllabus for today, or the agenda here. My goal today is to talk about Apple's levels of defenses and really the tools that come shipped with a new computer. So you open up a device for the first time, what security tools are already on it? And all of them get lumped into one of three main levels of defense. So the tools we talk about today are all going to fall into one of those, and those are checking for malware, blocking it, and then remediating or removing it. So I want to give a quick run through of the tools we'll talk about so you can kind of see how the flow of this is going to go. So with our check portion, we're going to discuss file quarantine and Gatekeeper. We'll then move into the block section, which will be TCC and Xprotect. And lastly, remediate. And last year I talked about MRT, or the malware removal tool that used to be used for remediation, and now Apple uses Xprotect Remediator, or the abbreviation XPR. So let's get started with file quarantine. So when we talk about what it was introduced back in OS X 10.5 Lion, back in the good old days of OS X. And really, it's designed to just remember what you obtain from a network. So when you open it, it gets checked, and you can allow or not allow it to run. And this is really looking for unsafe file types, and it happens from Spotlight, the dock, and Finder. Doesn't apply to scripts, but most applications. And right alongside file quarantine is something called app translocation. So after you've approved a file to run from the internet, it will be translocated, so it will be moved to a randomized location, and it's designed to prevent plugins from loading as well. So if you tap into endpoint security, or ESF, or the endpoint security API, however you want to call it, the path might look something like this. So in the root directory, private var folders, some random characters, and then a few more folders. And the idea here is this path won't be replicated more than once, so it allows malware to not be able to see where it's first executing from. So to kind of look at this in action, how file quarantine works, say we want to reverse engineer something, so we want to download the binary ninja tool from Vector35. And so in typical installation workflow, we're going to mount our disk image to volumes, drag it to applications. But when we finally go to applications and go to launch it for the first time, we're going to get an alert. And this is from Apple's Core Services UI agent that provides you this alert. And it has some context here. So not just the name of the application that was executing, but also where it's coming from, what browser, and the time as well. So if I downloaded this 2 months ago, it would show me the time that I downloaded it. So under the hood, what's happening is when you download something, an extended attribute gets applied to it. And you can look at the extended attributes via the xadder command. So this disk image we downloaded, we have two extended attributes, com.apple.macl, and the one we're going to talk about, which is com.apple.quarantine. And if we print out the contents of that attribute, we have 4 fields here. So the nice thing about this attribute is it's applied to everything within that application bundle recursively. So regardless if I move files around within that application bundle or move a specific file out, it will still have that quarantine attribute. And so what these attributes are telling us is this first item here, 0083, is just a flag. And in this case, 0083 will force a full check by Gatekeeper, meaning it was just downloaded. Gatekeeper hasn't checked it yet. Now, the reason for 0083 is unknown to me. It's just a binary representation. And so once you have approved it, that will eventually be updated to a different number. And the most common one I seem to see is 00E3 or C3. Again, why those numbers are the numbers they are, I'm not certain. So the next one here, and this one is actually interesting to me, not just that it's a timestamp, but this is an epoch timestamp. And why it's interesting is only a year and a half ago, this timestamp wasn't in epoch time, it was in Mac absolute time or CF absolute time. The difference is relatively trivial. It's the epoch time is the second since January 1st, 1970, where CF absolute time is the second since January 1st, 2001. And why Apple changed it, I'm not sure, but I found it interesting because up until this point, that was the only Apple mechanism I actually saw using that CF absolute time within their security stack. Most used this epoch time. So Apple uses that now, and this is the time it was downloaded. We also have the origin or the browser it was downloaded from, pretty self-explanatory. And then lastly, a UUID to associate this with. One of the great things about macOS is its logging, and this could be an entire talk in and of itself. But you can see log messages as you are trying to open something or just on your system in general. And in this case, we can actually see what Apple is doing behind the scenes by tapping into the subsystem called com.apple.launch services. And you can, again, do this from either the command line via the log show or log stream commands, but you can also just do this from the console app like I'm doing here. And again, in this case in particularly, we can see on the bottom that it is the signing ID com.vector35.binaryninja, the application we were just running, and that category called CAS is the certificate authority. So in this case, we are seeing the log message for Apple checking the certificate information of our binary that we attempted to run. And again, you can see in the top right the subsystem filter, so you can do this at scale and see a lot of messages here. A lot of times via your MDM, you can get log messages as well. So that's a bit about file quarantine. So we'll pivot to Gatekeeper. And I think a lot of times this all can get convoluted, file quarantine and app translocation and Gatekeeper. So I did my best to separate these. So file quarantine will notify you when you try to open an app from the internet. And when you approve it, it will be translocated to this randomized directory. And then at this point, Gatekeeper will do its check to ensure that only trusted software is running on your machine. One of the easiest ways to see this in action is via a command line binary called SPCTL or System Policy Control binary. And you can run this against any application and see two really important pieces of information. And that is whether it's notarized or not, and also whether it is code signed. So we're going to talk about both of these, and we'll talk about code signing first. So very Simply, code signing is just a 10-character identifier that is assigned to a developer. Now, you can pay $99 for a developer account and get a developer ID, and this allows you to build and distribute software. And just for transparency, I use developer ID. Apple, in their endpoint security, refers to it as a team ID, so just know that developer and team ID are equal. So again, this is Apple forcing, basically trying to get software to be developed from trusted sources. And there are workarounds for this that we've seen malware authors use, whether it's stealing developer identification or buying a developer ID and then using it maliciously. So in this case here, I'm using Huntress as the example, is their 10-digit identifier. And then, of course, this application is also notarized. So notarization is a service, an automated service that Apple provides, and you can submit your application to Apple, and they will check it for malware. Relatively quickly, too. It can be anywhere from a minute up to 5. So a quick process for checking something for malware. And you can notarize macOS applications or non-app bundles like system extensions, disk images, or even like flat installer packages. So how this works behind the scenes is you will take your developer will take their new application they're building, and they will then submit it to Apple to be notarized. At that point, Apple will scan it for malware and return whether it has been successfully notarized or not. And then on Apple's server is a certificate that will basically, when you go to run it from a device, it will check and see if it's signed. However, there is an additional step you can take to not have to connect out to Apple's server to check signing or notarization information. So developers can then take that certificate and staple it to their application. So that way you can run it offline and Apple can still see that it is notarized. To me, one of the most interesting parts about Gatekeeper is that it is designed to be overridden. And this is a purposeful design by Apple. So there are options to restrict software that can run, whether it's only from the App Store or also trusted sources. But you can get around this with relative ease by going into your privacy and security settings and then click the Open Anyway button. And this is probably the longest way to do it, the most time intensive, and it's not even that long in the first place. But probably the most well-known one is to right-click your app or two-finger click your app and click Open. And unfortunately, malware has seen that this is used as well and has built this into their social engineering techniques. So if you download this malware called Schlayer, it's very well known for using this type of technique. You mount the disk image, and it actually shows you how to bypass or override Gatekeeper. And it's very simple. Two-finger click the install Flash player, of course, on the top, and it will execute their binary because you stepped over Gatekeeper's protections. So that covers the check portion. As we pivot to block, TCC doesn't quite fit perfectly in any one of these. I feel like it kind of floats between all three. So it's in the block section. And TCC is an acronym that stands for Transparency, Consent, and Control. And it's a little, I think, more straightforward to understand as opposed to Gatekeeper and File Quarantine. But it is a framework for regulating applications' permissions and managing their access to your user data. So I think the best way to illustrate this is just a quick demo. This is an application called QLab for making music cues and things like that. But when I go to use the microphone, I get a pop-up that says, do you want to allow this or not? And then same goes with the camera. And this is basically what the user sees when it comes to TCC, and how that looks in your system settings is, unfortunately, with the system settings, it's a little harder to read than the old system preferences. I miss them so dearly. But here is a full disk access pane where you can toggle on and off for full disk access. And next up is the camera, as you just saw. You can see what applications I've allowed to use my camera or not. So how does this all look under the hood? Well, TCC is just some databases that live on the system. And there's at least 2 per system. So there's one at the root directory in library application support com.apple.tcc. And then there's one per user. And the primary difference here is that things like full disk access, that has the most access to your quote unquote private information or sensitive information, is going to be in that root directory. And so these are SQLite databases, as you can see, and we can actually just open these up from the command line or any kind of database SQLite tool. And we can look at the tables, and we're going to open the primary table, which is called access, and there's going to be a ton of information here. So we're going to pare it down quite a bit. So first, we're going to select the 4 columns that I think are the most telling, which are client, auth reason, auth value, and service, and we'll talk about what those are. And as you can see, we still have a ton of information here. So we're going to specify this service. And again, I'll expand on this, but this service is KTCC service system policy all files, which is full disk access in this case. So we'll pull one of these out and kind of step through what these different columns are. Again, we'll use Huntress as the example. So first up is our client, who is doing the requesting, and it uses the signing identifier, which is commonly in this reverse DNS notation. Typically, it's something like com.company.product name. Next up is an integer called auth reason. And this is basically how that TCC permission is set. And you can see here it can be set by an MDM or a various number of ways. Here we had number 4, which is set by the system. Next up is the auth value, and this has changed in the last few years. There used to only be 4 options, which were 0 through 3. And they recently allowed these last 2, number 4, number 5. And I find 5 the most interesting in that it allows you to assign a boot session to that permission. So meaning the next time you restart your computer, it's going to clear that TCC permission. And this allows you to basically give temporary permission to something until you decide to reboot your computer. Last but not least, here is our service. Again, this is full disk access, and there's a long list of services that range from iCloud information. Again, on that 4th line, you can see full disk access, screen capture, access to your documents, your desktop, your camera, everything to endpoint security, and of course, a lot more. So one of the more nuanced pieces of TCC is how it interacts with MDMs. So when TCC and MDMs collide, you get a property list called MDM overrides. And this also lives in the root directory right next to your TCC database, and it's just called the MDM overrides property list. And this is where MDMs store the TCC permissions that they are deploying down to an endpoint. Now, there are some difficulties that come along with this in that it's not reflected in the system settings UI. And because of this, it makes it harder to debug issues. And I say this because most of the administrators that I talk to at Huntress, coming from Jamf, where everyone is a Mac admin, but at Huntress, the majority of admins I deal with are Windows admins dipping their toes into the macOS space. And to try to explain that if they are sitting on a machine and they go into the system settings, they can't see what TCC permissions are applied, can be a headache for them. So trying to find this bridge between Mac and Windows here. The second part of block is, of course, Xprotect, which is one of my favorite tools on macOS. I spoke briefly about this last year, so I won't go into as much detail. But a quick overview, if we dive down a long list of directories here, we come to 2 Xprotect folders or applications. One is a xprotect.app and one is an xprotect.bundle. The xprotect.bundle is really the core Xprotect tool. And within this bundle is 5 files. So a quick overview of those files. The legacy entitlement allow list is pretty self-explanatory. MacOS that need a legacy entitlement. We have an Xprotect plist. This is looking for basically static-based detections based on the URI type. We have a meta.plist. I find this one interesting. It looks for malicious extensions as well as outdated Java and Flash. The gk.db, a Gatekeeper database. Earlier we talked about malicious developer IDs, and malicious developer IDs are stored here, and Gatekeeper does a check against them to see if a developer ID is listed in this database to just immediately block it. And then last is the Xprotect.yara file, and I think this is the fundamental piece of Xprotect. So it's looking for malware on a system using Yara rules. And just doing a quick search, this is what it told me Yara was. But the fundamental point behind Yara is you can specify conditions for rules, and if the malware or a file matches on those, you can alert on it and categorize malware into families. So if we look at that Xprotect.yara file, there is 335 rules in there, including 3 private rules. And this stems all the way back to 2007. And you can have multiple rules for a malware family. So based on the variation of malware, take adload, a very prevalent macOS malware. There are different ways we can detect it via different YAR rules. So there's, I think, at least 5 or 6 adload rules for atomic stealer and info stealers and things like that. It's a large file with a lot of rules that Xprotect is using to alert on malware. So that brings us to Xprotect remediator. Or as Apple refers to it as Bastion or Bastion rules. So this is located in the xprotect.app, which is next to that .bundle file. And there are a pile of macOS in here, so compiled binaries. And there are 24 as of last night, if Apple hasn't pushed a new update yet, I hope. And these were kind of a black box until a few months ago. And I had a coworker named Alden Schmidt who came on to work at Huntress as a detections engineer. And right about the time he started, he released a blog that basically took apart some of these binaries. So within these Mako binaries, there is a constructor attribute that will run before main called mod init func. And Apple uses these constructors to decrypt the global strings before main executes, which oddly enough is how a lot of malware operates. It will try to encrypt its strings. So if you just first glance, you won't see any strings to note here. But using a XOR key, which you can see where it says I.B, using a XOR key on that line, you can actually decrypt these and see that these are YAR rules embedded within the binary. So, for example, if we were to look at just that list of binaries and come across one that's called rank stank, to me that didn't mean anything the first time I saw it. But if you look at this YAR rule, you could either grab this rule and run it against VirusTotal or reversing lab search. But if you look at it, these strings are also the strings that were uncovered when the 3CX supply chain attack happened. So this is a remediator that's looking to remove evidence, or not evidence, that's probably the wrong way to put it, but remove the malware that was brought on by the 3CX attack. Now, Apple has also been dipping their toes into behavioral-based detections via the Xprotect behavior service. This is, again, just another SQLite database that you can just dump to a CSV if you want. And what's interesting, I don't believe that Apple is taking action on these yet. So if you trigger one of these, you're not going to necessarily get an alert. Historically, you would see rule names here on the left side. They would be called Bastion Rule 1 or 2. But now you see things like macOS.messages.generic. This is just from my prod machine. And then executing paths. So the path of what happened. What I find interesting is like all these are either Defender or Edge. And then the signing ID that goes along with it. And there's a lot more information. I won't step through all of this, but you have both process information and responsible process information. And what that allows you to see is, for example, if I were to pipe a curl command to bash, you'd actually be able to see that those two were associated via that responsible process. So that's a lot of information about just macOS internals, but really, what does this mean? And what does this mean for you? So, back in the mid 2000s, this anchor from The Daily Show and Kate Bosworth's husband were in this series of commercials. The I'm a Mac, I'm a PC commercial. I don't even need to go into it in this room. And I get a lot of flack from my coworkers about the whole Macs don't get viruses thing. And even though it's not true now, and I think Apple obviously realizes that, this sowed a lot of seeds of thoughts that Apple just doesn't, or macOS in general, just doesn't need EDR. And we still see that permeating today. I still hear that from administrators and even end users. You think of just if you call up your uncle and he tells you he's a Mac, that he doesn't need an AV. And so this idea that Macs don't need additional protection, at this point, I just don't think is true. Because up until now, before Apple released behavioral-based detections, what they had to do was reactive. So a new piece of malware comes out, put out a YAR rule or a signature or even a remediator for it, and they haven't been able to be proactive until this release of behavioral-based detection. So I think once the behavioral-based detections start alerting and telling users what happened, I think Apple on its own could be a security part of your security stack in general. But I think it's very wise to add a reputable EDR or AV to your stack if you haven't yet. And I know, kind of preaching to the choir in this room. So a few references I want to mention and some further reading. Again, Alden Schmidt, who's a brilliant reverse engineer and detections engineer, has a great blog on Xprotect Remediator. Howard Oakley, if you don't read his stuff on macOS, you're missing out. There's so much gold there. And then if you want some further reading, I have a pile of blogs up at huntress.com.